In this 30-minute tutorial, I'm going to show you how to build from scratch the audio system that I used in Blackthorn Prod's Christmas Horror Pass the Game Challenge, as well as go through some of the basics of Unity's audio mixer and how to use that mixer through code. This might not be exactly beginner friendly because I will assume that you know about arrays and singletons and some of the basics of programming, as well as how to use the Unity game engine. Hi, today I wanted to show you this audio system that I often end up using in game jam games because it's robust enough to get a lot of fine-tuning for a simple game project. And by the end of this video, you should be able to very easily play and control sounds in your Unity game. Now, if you just want the code for the classes that we're going to build today, they're down in the description. Just click and download and use them however you wish. Now, if you watch Blackthorn Prod's channel, this project might look familiar to you. This is from the Xmas Horror Pass the Game Challenge, and we're using a character controller by LazyTeaStudios. Link in the description. Now, as you may notice, this scene is completely silent. So let's start with some basics of playing audio in Unity. Let's create a new C# script, and let's call this audio system. Starting off with something really basic. You may know that the audio source class has a static function called playClipAtPoint, which takes in two arguments, a clip and a position to play it in, as well as an optional volume parameter. We won't be using that. Let's add this reference. Now let's give that a shot. If we add this to the scene and give it a clip, I have some clips from the project. Now for testing, I'm going to trigger the sound with just input. And now if I press G, it plays the pickup sound from the game. Now you may notice that if we keep going right, the sound gets softer and softer. That's because I'm telling it to play at 0, 0, 0, which is the world origin, which is just left off here, which we can't get back to. Just replace vector 3.0 with the place where you want the audio to play, usually like at the player's feet if you're playing footsteps or somewhere else. If this is all you need, then there's no need to make it more complicated. Now we're going to use this as a base, and I'm going to show you a simple system to get a lot more control quite easily for an audio system. If we look at this function and press F12, we can go to the decompiled version of this, and now we're simply going to yoink this code. So copy paste. Now at this point, we could simply remove the audio source class from the start and just give it a volume. And this would work exactly the same. What this function does is it creates a new game object, calls it OneShotAudio. It puts it at the desired position, adds an audio source component to it, caches it within the function, inserts the clip, applies spatial blending, volume parameter, and tells it to play, and then to destroy itself after the clip has done playing. This part of the code simply takes into account Unity's current timescale, so the object is destroyed at the right moment. We're going to start building upon this. Let's add a helper class down here. We're going to call it sound. It doesn't have to be a mono behavior. Actually, it can't be a mono behavior. And now here we can add some parameters that we would want to control while playing a sound effect. Stuff like the volume, pitch, perhaps the spatial blending, as well as we of course need the actual clip. We're going to use this class to store information about individual sound effects that we want to send to this audio system to play. So now let's refactor this method to take in a sound instead of taking in just an audio clip. We're going to remove the optional volume, and we're going to change this to be a sound instead of a clip. Call it sound to play, and then we'll assign the clip to be sound to play.clip, the spatial blending to be sound to play.spatialblend. Same with the volume, and replace this reference with either the audio source.clip or the sound to play.clip. They're the same, so it doesn't matter. Now for debugging, I recommend changing this to something a bit more descriptive. We could display the name of the clip. So most of the time we'll know which class called a sound to play. Now let's rename this function to play sound at point, just so we won't get confused. Now this is already enough to play footstep sounds. I'm going to add a class to the player called PlayerAudioHandler. Generally, you want your scripts to be decoupled, so there's no reason for the controller to actually know about something that plays audio. Here we need two things. One, we need a sound. And then we need a public function that we can call from an animation event. I personally recommend you have a separate function that is called from an animation event, and then you have the actual function. This will make debugging easier. If you can't figure out why something is being called, then you can see, oh, right, that something is calling this function from the outside, but you have an entry point that is not the actual function. So I recommend doing it like this. So just public void on footstep animation event called, and inside we're going to call a function called play footstep and generate that function. And now here we just say audio system dot play sound at point, supply the sound, and where to play it. We're gonna play it at the player's feet. Okay, now let's hook this up. We're gonna go to the player and animation. Now there are several ways you can time footsteps, but one easy way is to time them with the animation. It is a little bit coupling of systems, but you usually want footsteps and the animation of stepping to be played at the same time. So let's look for a frame when it looks good. That looks like a step, but let's play it one frame before, just because I know it'll look better. Then we click this button, add event, and then we go player audio handler and on footstep animation event called. Pop. Then we find the second frame, which is here, and again, one frame back, add event, same thing. Now let's drag some references. Here, notice we have absolutely nothing visible in the audio handler script, but we need to see the sound. This is because in order to be able to assign references and serialize custom classes, you need to give them the attribute system.serializable. What we're essentially doing is telling Unity that we want you to be able to save values in this class. Now let's save. And notice now we have a sound here. And this expects us to give it a clip, volume, pitch, and spatial blending. I have some footsteps that I made in the project when I call it with a volume of 1, pitch of 1, and spatial blending of 1. Spatial blending 1 is fully 3D, 0 is fully 2D. Let's try it out. And notice how we now have footsteps. If you're wearing headphones, you might hear that actually the spatial blending being at 1, the footsteps are always sort of playing behind us. Because this is a 2D game, we might want to have the spatial blending at 1. And because of the system, it's as easy as 0, and now it's fully 2D. Okay, the sound is a little bit high, maybe lower it. So let's add a volume of 0.2. Much better. Now maybe this is all you need, but let's make this a little bit fancier, a little bit robust. I don't know if you noticed this, but here where we're playing the footstep, there's no reference to an object here where we're calling the sound. That is because this function is static. Static means that it belongs to the class itself and not an instance of that class. So actually, what I can do is go back to Unity. I can delete the audio system from the scene and it has no effect. Audio works just as well because it doesn't have to be in the scene. In fact, you can even remove mono behavior from it and it'll still work exactly the same. Now, for some instances, you might actually want to have a reference to like a singleton audio system, and we'll get to that later. But if this is all you need, thank you for watching. And now we're just gonna make this a little bit fancier. First of all, we probably would want these to be limited to some reasonable range. So let's add a range attribute. For pitch, the range goes from 0 to 3. Now also, I'm gonna show you something here. Let's add a new sound. Footstep sound 2 sounds good enough. Notice how the values are at 0. This makes it so that we always have to assign them to some specific value that maybe we want. I don't like that, so let's make our lives easier. We're gonna add a constructor to the sound class. A constructor is a method that is called whenever that object is created, and you can use it to run some logic when that object comes into existence. So like when you add it to a class. A constructor is most often public, and it has to have the same name as the class. And here we can assign some default values. The beauty of this is that you can expand this to meet your needs. I'll show you some tricks later on. So now if we create footstep sound 2 again, Now you notice that it has default values of volume 1, pitch 1, and spatial plane 0. Exactly as we want it, and everything is within range. Perfect. Now currently we're only playing the same exact footstep sound over and over again. So maybe we would like to play several footstep sounds, perhaps randomly, maybe with some pitch variation. So let's add that functionality to our audio system. I feel obliged to say that newer versions of Unity actually have a component that does exactly this. It's called the audio container. It will give you a random clip with a random pitch variation that you can assign. We're just going to do this exact same thing in code in case you either are using an older version of Unity or you just dislike using this, or maybe just because you want to know how this can be done. We're going to write a function to get a random sound from an array. We're going to need a sound array and an optional parameter called previous sound. We're going to assign it to be null by default so that if you don't want to give it a previous sound, then it will work just fine. Now actually, this can also be a static function. So we don't need a reference for it. Now this is going to be really simple. First, create a local sound. Now you might be familiar with a while loop, but we're going to do a do-while loop. A do-while loop is the exact same thing as a while loop, except it is guaranteed to run at least once. So we're going to do while random sound equals previous sound, and in parentheses. Now within the loop, we're going to assign random sound to be a random sound from the array that we were applied. And after this, we return random sound. In case you're wondering why this works, it's because previous sound is supplied null. So if you do not supply the previous sound, it will simply select the sound, and if that sound is not null, it will return it. And if you supply it with a previous sound, it will pick a random clip, and if it's the same that it plays last time, it will do it again. So technically, it is mathematically possible to have an endless loop here, but the chances of that happening are almost zero as long as you supply it more than one sound. But let's make some protections for that. So before we actually do this, let's make a check. If sound's length is 0, now let's add some error checking here. I'm going to show you a neat trick. The log function accepts markup language, so we can type color equals FF0000. So fully red. There. And now if we supply it an empty sound array, it will give us a nice red error text, and then we want to return null. Now while we're doing this, because we're allowing for a null sound to be returned from this function, we might send actually a null sound to this function at some point. So let's add another error check here. We could check the clip. So if sound to play dot clip equals null, then we're going to give ourselves an error message and return. So let's copy this. Now, because this is a static function that you can call from anywhere, you might at some point, especially if you're only getting errors and you're not seeing the name of the clip you're playing, you might be confused as to what is causing that error. So here's something that I like to add to this function to make debugging a little easier. So I'm going to add here a parameter that is of type object, call it sender. If you've worked with events, you might be familiar with a sender. So we're going to change the name of the temporary game object to be sender.toString plus a space in between, or maybe a colon, plus sound to play dot clip dot toString. And now we can see what object called what sound. And also we're going to add it here. By space plus sender.toString. And now we're going to have an error here because it requires a sender. So this is easy. You just type this. And now we can see that the player audio handler sent a null sound to play if that ever happens. This is me from the future. I actually made a stupid mistake here. Because we're checking the clip in the play sounded point, actually this will return a full null sound. So actually, what you can do is actually you can return a new sound here, and then the clip will be null here, or you can keep this as just null and simply check if the sound to play is null. And that would make it work properly. And this is what it looks like when you get those error messages. Okay, so that was a lot of work for just some quality of life issues, but let's now actually hook up the system to play random footstep sounds. So here, instead of footstep sound, we're going to supply it a sound array of footstep sounds. You might actually be explicit and call this footstep sound array. And I'm also going to use the previous sound functionality, so I'm going to add a private reference here, private sound, previous footstep sound. Now let's use our helper function. So sound to play equals audiosystem dot get random sound from array, footstep sounds array, and we're going to supply it with the previous sound. So we're going to supply it with the previous footstep sound. Now, after we have gotten sound to play, we're going to play that sound, and then we're going to assign the previous footstep sound to be sound to play. And that's everything you need. This system will already work. Now let's just drag some references. Now you're about to see some downsides of this system. If I now add an element, like 2 or 3 footsteps, you notice that the clip is completely empty and actually the constructor, for some reason, doesn't get called. I don't know why this happens. But let's assign these references and set these settings to what we want them to be. And there we have it, footstep sounds being played randomly with never the footstep sound twice in a row. Again, if this is all you need, thanks for watching. Now we're just gonna add some more goodies to this to make our lives even more easier. Wouldn't it be nice if we could add even more variation to this by having the pitch vary just a little bit with each step? Now, how could we do this? Like, we could obviously write our own function here in the player audio handler and do that just for some footsteps, but maybe we don't want to. So maybe we can add it to this, again, as an optional parameter. So let's say, after the position, we could add a bool, use pitch variation, and by default, we're gonna set it to false. Now, those of you who were keen-eyed actually might have noticed that we're not setting the pitch anywhere here because this is still just a function that we copied from Unity's own audio source system. So actually, let's add that functionality. So the audio source dot pitch should be sound to play dot pitch. And now if we're going to use this pitch variation, we're going to write here if use pitch variation. In that case, we're going to vary the pitch just a little bit. So here we're making the pitch to be the default pitch plus something a little bit either below 0 or top 0. Now here's a limitation. Maybe we don't want each and every function call for this to have to supply some pitch variation. We could add it here as a parameter that maybe we can change. Currently, this is just a magic number. You might actually want to do something like this and then add these values here just to make your intentions clear as to what you're doing. But since we're working on a game jam and this is just for us, I'm pretty sure I can understand what this is doing, and I know I've written this. And this is already enough to actually make sounds sound just a little bit different. And again, we could do the exact same thing here with some volume variation, but I'm not going to do that now because I don't feel it's necessary. So you can barely hear it, but there's some more variation, and you can keep running and you will almost never ever hear the exact same sound twice because there's just a little bit of float variation going around. Next, let's have a look at some simple volume settings and a reason why you actually might want to have the audio system as a mounting behavior in the scene. Now for this, we're going to want to add an audio mixer to the scene. So right click, create audio mixer. I'm going to call this main mixer, and then I'm going to place this in a resources folder. Create folder, and it has to be named exactly like this. Resources is a similar kind of folder name as editor, that is a special Unity folder that you can use to load stuff at runtime. I'm going to place the mixer inside here. Now we're going to do a little bit more setup. We have the master volume here, but we can't control this yet because we need to add it as an exposed parameter. It's kind of convoluted how you do this in Unity, but you have to select the slider that you want to expose a value from, and up here you have to right click, expose volume of master to script. It'll show up here as my exposed param, the volume of master. Now I want to rename this master volume. This is a string reference, so be careful what you type here. Next, let's create a UI element. I'm not going to talk about setting up UI. I'm assuming you know how to do this. Now here we have the basics of a volume slider. It's not pretty, but it doesn't have to be for our needs. Now here, let's add a component and call it audio settings menu. We want a reference to our mixer and as well as our slider. The slider is in the Unity UI namespace. Now in Awake, let's get these references. So the main mixer we have to load from the resources. So just type main mixer equals resources dot load, and we want to load a generic type of audio mixer, which is called main mixer. This is again a string reference, so make sure that it's correct, as an audio mixer. There, now we have a reference to our main mixer. As long as this is correct, I'm gonna check. Yes, that is in fact what we called it. And next we're gonna hook up to the slider's onValueChanged event. So a slider has an event that is called whenever you touch the slider, and you can use the value of the slider to do something. In this case, set the volume in the main mixer. So this is how you do it. Master volume slider dot onValueChanged dot add listener, and then this takes in a value. Value is what is inputted into this function from the slider itself. So you can type value and then use a lambda expression, and we're going to call a function here, which is going to be called set master volume, and we're going to put in the value. Now generate this method. You could just technically input the value from the slider, but the slider value goes from 0 to 1, but the mixer goes from +20 to -80, because this is in decibels, and the slider simply gives us a normalized value. Now you could change the slider's min and max value to go from +20 to -80, but that wouldn't give you the desired result, as a volume scale is logarithmic and not linear. So I'm going to show you a formula that I just have this typed down, so don't feel bad if you don't remember it or you don't fully understand it. But float decibel volume equals mathf dot logarithmic 10 value times 20. Now there's a problem with this. It won't go exactly to 0. So here we need to add another check. So if value equals 0, decibel volume to be -80. Now we can go to the main mixer and set float. You see, it takes a string and it takes a float value for what we want to apply. So here we're simply going to type, we want to affect the master volume, this is a string reference, remember, with the decibel volume. And if I'm not mistaken, this should work. Now, after we've supplied it with the master volume slider, if we press play, we notice that when we move the slider, it will simply take in the value and we can slide it from 0 to -80. And now it goes on a decibel curve. But now, notice if I set this volume to 0, and I'm going to just turn off this canvas, if I walk, there's absolutely no effect on the audio whatsoever. What's going on here? Well, if you notice, we're actually not playing sounds through the mixer. We're simply playing sounds sort of like in the wild. So this is something that, as I mentioned, you might actually want to have the audio system as a reference in the scene. I'm going to add to our sounds a public audio mixer group. I'm just going to call this mixer group, because we need to supply this in order to play sounds through the mixer. And here we're going to add that parameter. So audio source dot output audio mixer group equals sound to play dot mixer group. Now, because this Unity project has an audio mixer, we can see that if we click the mixer group, it says, would you like to play through the master group? And we say, of course, yes. Now, this is a choice you have to make. Do you want to assign this manually if you only have one master channel in your mixer? If you don't have, let's say, UI sounds, ambient sounds, SFX, shooting sounds, whatever, you might actually simply want to have this as a default handled by the audio system. And we're going to do that version now. Now, if you simply add more groups here, like I could call this like SFX, and then I could play sounds through the SFX group. I could definitely do that. But this is not necessarily something that you want to do if you have a lot of sounds. So let's now return to an instance where we actually want to have this in a scene because we need a reference to a non-static field. So I'm going to add mono behavior at the end again, and I'm going to add an awake method where I'm going to make this a singleton. If you're not familiar with what a singleton is something that you only have one global reference of in your entire project, and you can access it from anywhere. And this is how you do it. You make a static reference to an audio system, and it's usually called instance, often actually with a capital I. Now we're going to assign this instance and enforce that there's only one of them in the scene. So if instance equals null, then instance equals this, and else we want to destroy this .gameObject. So what it's doing is, if the instance is not set to anything, then the first mono behavior instance that is created will be the instance. And whenever another version of this is created, it will check, oh, this instance actually has already been set, so therefore I will destroy myself. And now we can have non-static fields, like we can have a serialized field called an audio mixer group called default mixer group. I'm now going to add this system back to the scene, and it now asks me for a default mixer group. I'm going to say the master is the default mixer group. And now we need to refactor this code a little bit. So if sound to play dot mixer group equals null, meaning if we haven't supplied a mixer group to it, in that instance, the audio source's output audio mixer group will be the default mixer group. And you notice we have an error because this is we're referencing a non-static field, because only the instance has a serialized field that actually holds any data. So here we have to add instance dot default audio mixer group. And this is why you need it to be in the scene, because it needs to have a reference to a non-static field. And if you don't need this, then you don't need to have this in the scene. But we need this. And else, if it is not, then the audio source's output mixer group will be sound to play dot mixer group. And now if I set this to 0, you can see the slider went down all the way down to 0, and we can't hear a thing. We can still occasionally see that the SFX group jumps up because one of the sounds still has the output mixer group sent to the SFX channel, but it doesn't play a sound because SFX is going through master and master is set to 0. That's about everything I wanted to talk to you about today. If you end up using this system anywhere, please let me know in comments or on itch. I would really want to know if I was helpful to you. And if you have any questions, leave them in the comments. Now, if you watch this video all the way through, be sure to comment "I hate mixer groups" down in the comment section so I know everyone who watched all the way. And if you just want the code, remember there's a more robust version of my audio settings class and the audio system as links in the description. Feel free to use them commercially or non-commercially and edit and redistribute as much as you want. And this is Darkroom signing off.